So, just to help you along, there is something called, well, what the book calls symmetrical properties, but these are different properties that's based on the different parts that you are on your unit circle. So, remember last time we established that the x values are all cosines and the y values are all sine values. And just to simplify it, we wrote down that tan theta is equal to sine theta over cos theta. Now, the idea of this whole part is just to show you that this particular triangle is the same along all the different parts of the circles. You just have to do a quick adjustment. So, let's look at the first one. And I know it's not drawn very nicely, just presume it's the same triangle, okay? If this was, let's pick a different color. If this was cos theta and then sine theta here, what would this point be? If it's the exact same triangle but flipped. What's the only thing that's changed on there? Negative cos? Good. What about sine? It's the same. Alright, now let's just quickly think about tan theta. Is that positive or negative in that case? Because remember, it's sine over cos, or y over x. So is that negative or not? Yep. So negative sine theta over cos theta in this one. So in other words, in this region, as a summary, we have a positive sine, negative cos, giving us a negative tan. Alright, this one, what's the thing that's changed? Sine, now is cos still negative? So what does that mean for tan theta? So that means, as a summary for this one, we have negative sine, negative cos, but positive tan. Okay? And then on this one, what's negative there? Sine. So we're positive cos, negative sine, and then tan is going to be negative. So as a summary, we have negative sine, positive cos, and negative tan. What that means is, in each of these regions, you might notice that there's one thing that's positive, except for the first one. The first one has everything being positive. Does that make sense? So in the first region, everything is positive. In the second region, we have only sine being positive. In the third region, we have only tan being positive. And then in the last region, we have cos being positive. So we can summarize this using the following. We have an A for the first one. So remember, that's quadrant 1, and S for quadrant 2 for sine, T for quadrant 3, and then C for quadrant 4. So there's two ways to remember this. Number one, this is a really old saying. It still works for Melbourne, but it does not work for Sydney. And I learned this in Sydney, so it's really weird for me. All stations to central. Okay, so this one's good in the sense that it goes from quadrant 1 to 2 to 3 to 4, which means it starts with all for the first quadrant, then stations to central, like that. The other way of remembering it is remembering the word cast. So you start from quadrant 4 and then going in the same direction as your quadrants. But the only problem with this one is it starts from quadrant 4. It's up to you on which one you want to remember. It still kind of works for Melbourne because, you know, you go to Melbourne Central and most of the trains still stop there. So all stations to Central is still the one that I would think would be the best one to remember. But anyway, any questions? Should I pause so you guys can write this part down? Or are you all good? Now, what these are used for is they're used for you to evaluate stuff. So, if f theta is equal to cos theta, evaluate f of negative 6 pi. Alright, so let's have a think about this. Which way is the positive direction? Clockwise or anti-clockwise? Anti-clockwise. So, if we're trying to go in the negative direction, which way should we go? Clockwise. Now, let's see how much you remember about radians. How far have I gone? Pi. Pi. Remember, 1 pi is 180 degrees. So that's pi, 2 pi, 3 pi, 4 pi, 5 pi, and then 6 pi. Where are we? At the start. What's the cos value of the start? Yep. Very good. So in other words, what we would do is cos of 6 pi is equivalent to cos of 0. What's our x value at that point? It's an x value. 1. Okay? If you ever do need to think about what each of these are, best way to do it is to draw it like I did, and then just circle around until you know where you end up. Okay? Calculate the exact values of the following. So you have cos of 5 pi over 3. Now, the bit that I missed before, that you should probably add on, is this. And I was going to draw this at the start, but I totally forgot. You can actually simplify each part of these working outs by simply converting your angles so that you have the following match. This is the normal angle that you have at the start. Then this is pi minus x. This is pi plus x. This one is 2 pi minus x. The reason for that is, once you have that converted, you know which one is positive and which one's negative. So, just remind me, what's positive in the first region? All. Second one? Good. Third one? Fourth one? Alright, that's pretty much a summary of all the bits that you need. So this might be a good one to write down if you need to write it down. Now, how do we use that? 5 pi over 3, what's that closest to? Pi or 2 pi? If you're not sure about the pi, ignore the pi and just think about 5 over 3. Is that closest to 1 or 2? One. 5 over 3 is closest to 2, right? Because 2 makes it 6 over 3. Okay? So because that's closest to 6 over 3, we're going to use the 2 pi one. So we're going to use this one. So, 5 pi over 3, we're going to convert it to that writing. Then it's going to be 2 pi minus a certain angle. If you're not sure on which one it is, the hint is read the bottom. See how that's pi over 3? You just write pi over 3. You can have more, it might change a little bit later, but for now, if you're just working within the first circle, you can just read the bottom and that should tell you what it is. Alright. Now, is cos positive or negative in that region? Positive. So all you have to do now is you write cos, and you're converting it to what this is in that region, and you just add a positive or negative in front. We said it's positive, so we can just write cos of pi over 3, like so. It looks really weird, but what it stands for is the value is the same. Because remember, if you looked on the pictures before, I showed you that all the different values are actually the same. It's just whether or not it's positive or negative of the original. So because of that reason, we just have to convert it to positive or negative. Cos of pi over 3, or in other words, cos of 60 degrees, what's that? 1 over 2. Who thinks it's a half? Put your hand up. Who thinks it's root 3 over 2? Put your hand up. Who has no idea? It's a half. Gotta have it memorized. Alright, sine of 7 pi over 6. Let's try this again. Is that closest to 1 or 2? 7 over 6. 1? Alright. So let's firstly write the pi. Is it more than 1 or less than 1? More. And what's the fraction on the bottom? 6. Alright, so which region are we in? 1, 2, 3, or 4? Which quadrant, sorry? Remember it starts here. What quadrant are we in? 3. In quadrant 3, what's positive there? Tan. Is sine going to be positive then? No, so then we just simply add a negative in front. Then we write sine of pi over 6. Okay? In other words, you're converting it to whatever this fraction is, and like I said, you just check if it's positive or negative in the front. That's all you have to do, and then you just work out the value. What's sine of pi over 6? Sine of 30 degrees. Come on, gotta have it memorized. Gotta have it memorized. Alright, tan of negative 30 degrees. Now, this is still the same thing, you just have to check what region you're in. If you're going negative, instead of going upwards, you're going downwards. So what region do you end up in? 4. Is tan positive or negative in 4? Negative. So write a negative, then you just write tan of whatever that is. Alright. Tan of 30 degrees. Or, okay, it's 1 over root 3 or negative root 3 over 3. Either one is acceptable. Okay? Alright. These are all actually the same. Do you want me to go through them? I'll just go through them anyway. Alright, identify the symmetrical points to 20 degrees. At which point are these values the same as tan of 20? What this is telling you is draw all the different triangles and show what it is. If that's tan of 20, then that's also tan of 20, that's also tan of 20, that's also tan of 20. Each one of these being 20 degrees. Technically it's actually here, but anyway. Alright, which one matches tan of 20 degrees though? In which region is it positive? Other than 1? 3. So that means this one has the same value. Does that make sense? Okay, part B. Express sine of 6 pi over 5 as a first quadrant value. Now, what is sine in the region that it's mentioning? Or do you need to think about this first, on which region it is? Alright, which region is it in? 1, 2, 3, or 4? I keep saying region. Which quadrant is it in? Oh, 6 pi over 5. Is it more than 1 or less than 1? More than 1. That means we have sine of pi plus pi over 5. Okay. So now that we know that, is that positive or negative in there? If you don't remember yet, all stations to central. Negative. Add a negative on, then you have sine of pi over 5. Okay? Alright, part C. If cos of theta is equal to 0.6, what's cos of pi minus theta? What's the only thing that's positive in pi minus theta? Read the green text. What's the only thing that's positive in the pi minus x one or pi minus theta one? What's the letter? Sine. So is this positive or negative? Negative. So cos of pi minus theta is equal to negative 0.6. What about cos of 2 pi minus theta? Positive or negative? You might notice this gets really repetitive. Positive? Good. You just check which one it matches up with, literally. So if it says 2 pi minus the angle, then it's the same as having cos being positive. Alright. D. Which quadrant? Who thinks 1? Put your hand up. 2, 3, 4. Who's unsure? Who has no idea what I'm on about still? Alright, so this is closest to 1, and 7 over 6 is more than 1, because the 7 is greater than the 6, so it's going to be pi plus pi over 6. Then, is tan positive or negative there again? Positive, so we just write it as pi over 6, which is equal to what exact value? Gotta remember your exact values. Alright, now, this one's a little bit weird. This one doesn't match any of the other ones that we have here, because that's 3 pi plus pi over 3. But there's a way to do that. I'm going to take out the 2 pi first. Wait, 1 second. Alright, see how there's an extra 2 pi there? That just means you've gone through how many circles? 1 or 2? 2 pi is 360 degrees, so how many circles have you gone through? 1, right? If you've gone through once, where do you end up in? Yeah, you end up in 0. You end up back at the start. So that means this 2 pi can actually be ignored. Then you have 2 pi minus pi on 3. So is sine positive or negative there? Negative? Sine of pi over 3. Root 3 over 2, okay?